morning, students. Today we will be using these three basic integration techniques or formula to do close to 10 examples. Now let's start off with A. You are asked to integrate this. So by looking at these three formulas, which formula will you make use of? Let's look at the last one first. This is definitely out because you don't have a E here, E over here. Now you look at the second one. There's a power n here. This is power minus 1. Now minus 1, 5 minus x squared, all right, to the power of minus 1. So this n does not take on minus 1. All right, so your n here, n does not equals to minus 1 in this formula. But look at this f of x is to the power of minus 1. All right, so f of x is 5 minus x squared. If f of x is 5 minus x squared, you look at this, is this the differential of 5 minus x squared? No. But we can adjust it, all right? Maybe, perhaps we can multiply the numerator by minus 2. Now, if we multiply the numerator by minus 2, then we need to divide it by minus 2. Otherwise, these two will not be equal. Now, the numerator now is now the differential of the denominator. So we can use this formula now. So minus half into ln 5 minus x squared plus c. Now let's try to do B now. Look at this. This is out. Can we use this? There's no denominator. The denominator is 1. How about this? X is not the differential of 2x cubed plus x. So looks like we can't use any of these three. This one, we just need to expand. All right, there's no other, we can't use any of these three formula. So let's try to do it. So how to expand this? This is to the power of 3. Now you can use your binomial expansion. So this is 2x cubed to the power of 3 plus 3, 2x cubed square x plus 3, 2x cubed x squared plus x to the power of 3, then I close bracket, followed by dx. Now let's expand the inside bracket first. So what do I get here? 2 to the power of 3 is 8. 8x to the power of 9. How about this? 2 squared is 4. 4 times 3 is 12. 12 x to the power of 6. This one I will get 6 x cubed to x squared here. So is x to the power of 5 plus x cubed dx. Okay. Now I multiply x into the expression inside the bracket. I will have integral of 8x to the power of 10 plus 12 x to the power of 7 plus 6 x to the power of 6 plus x to the power of 4 dx. Now this is a direct integration. So I have 8 over 11 x to the power of 11 plus 12 over 8 x to the power of 8 plus 6 x to the power of 7 divided by 7 plus x to the power of 5 divided by 5, and then of course plus c. Now this one we can simplify it to 4. No, I can divide by 4. So this will be equals to 3 over 2. Okay. Now let's move on to C. Now for C is very direct. We will choose formula 3 because that's the only one that has a exponential. Now, to make use of this, we must make sure that this part here is a differential of this. Now your f of x is 4 minus fx. You differentiate 4 minus fx, you get minus 5. But this is 1. So what we can do is we put a minus 5 here. E to the power of 4 minus 5x dx. Now we multiply this by minus 5, so we have to compensate it by dividing it by minus 5. So now with this, we can make use of this formula because this is the differential of the power. So you have minus 1 over 5. So this will become minus 1 over 5 to the power of e to the power of 4 minus 5x. Then of course, don't forget the plus c. Now how about this expression here? This how to integrate 2 tangent x. Now it seems like 2 tangent x doesn't fit into any of these 3 formulas. So what you do is, if you look at it properly, tangent x can be rewritten as sine x over cos x. You differentiate cos x, you get sine x. So we can use the green formula. So you got 2, you take out the 2 if you want. So you have sine x over cos x. Now differential of cos x is minus sine x. So you can put a minus here. Integration of minus sine x over cos x. Now the numerator is the differential of the denominator. So it fits into the green formula. So this will be equals to minus 2 ln absolute value of cos x plus c. We will do a few more examples, and please continue watching the video. Hi, we will be doing another 5 examples on the basic integration techniques. Let's begin with E. Now this is 1 over 4x plus 1 cubed. Now looking at this is out. We don't use this formula because there's no E here. And there is a denominator, but the numerator is far away from the differential of the denominator. Now, the closest to this would be this, okay? Now, but this one has a denominator. Of course, we can rewrite it in this form. 4x plus 1 to the power of minus 3. Now, we need the outside to be the differential of this. So the differential of 4x plus 1 is 4. So what we can do is, we put a 4 here, then this is 4x plus 1 to the power of minus 3 dx. Now, we need to multiply by 1 over 4 here, otherwise this will not be equals to this. Now, this part will then be the differential of 4x plus 1. So right now we can make use of this formula. What would that be? That will be equals to 1/4. Now, differential of this, what you need to do is you add the minus 3 to the power of minus 3, you add 1. So this will then becomes 4x plus 1 to the power of minus 2. Now you need to divide by minus 2. And then you get 1/4, or rather minus 1 over 8. And then you have 4x plus 1 to the power of minus 2 plus c. Now let's go on to f. Now for f, you notice that there's a e here, so we will be using the third formula. And differential of sine x is cos x. So this is just e to the power of sine x plus c. Now let's move on to this example. Now perhaps we can rewrite it in this form. Let me change the color. Root, you can write it as to the power of half minus 1 minus x to the power of minus 2 dx. Now, which one will you use? We will use this form. Alright, we need to make some adjustment. We must make sure that the outside is the differential of whatever is inside the bracket. So we make this minus 1. If we put this minus 1, you must multiply by minus 1. Minus. Now same thing here. Because the differential of minus x is minus 1, so I put a minus 1 here. But if I put a minus 1, I must multiply by, I must divide by minus 1. So this one becomes plus 1 here. Okay, so this is the differential of the inside function. So what I need to do is, half plus 1 is 3 over 2. Divide by 3 over 2 is the same as multiply by 2/3. Now same thing as here. Plus minus 2 plus 1 will get minus 1, and I have to divide by minus 1 over here. Over here I can rewrite it as this. 1 minus x to the power of 3 over 2 minus 1 minus x to the power of minus 1 plus c. Of course, you can write it as 1 over 1 minus x. Okay. Now for this, let us multiply it, because this is a product of 2, and this is not the differential of whatever is inside. So it's easier if you multiply them out. So you got e to the power minus 3x plus e to the power minus 2x plus e to the power minus x dx. Now how to integrate this? I have e to the power minus 3x over minus 3. And then this one I will have minus e to the power of minus 2x over minus 2. Because it's a plus, then over minus 2 will become minus. Same as this, likewise. Plus c. Now, how about this? Differential of cotangent x is minus cosecant square x. So this is not the differential of this. Now, if we differentiate cosecant x is minus cosecant x cotangent x. Oh, it's quite close, right? Except for the 3. So we need to make some adjustment. Now, let's differentiate this and see what happens. Differentiate cosecant 3x. You will have minus 3 cosecant 3x cotangent 3x. Now this is 2 cosecant x cotangent 3x. So for this to be 2, you need to divide by minus 3 and times 2. So this is minus 2/3 cosecant 3x dx. Okay. Now integrate both sides. What will you get? This I will get minus 2 over 3 cosecant 3x. So this is my answer to I. Now for that, we have come to the end of basic integration techniques. In the next video, I will be showing you, or rather I will be teaching you integration by parts, and I will do a few examples. For that, we come to the end of this question, this topic. Thank you very much. Thank you for watching.